Hello and welcome to the session on MyTile, a cloud-native storage engine based on TileDB. My name is Seth Shelnutt. I'm the Chief Technology Officer at TileDB. Before we get started today, I'd like to say a big thank you to the MariaDB Foundation for putting on Server Fest 2020. I know the pandemic has changed the plans of the usual MariaDB conferences, and we're very appreciative of them getting this put together. Today we're going to talk about what is TileDB, an overview of MyTile, the use cases of MyTile. We have two use cases we'd like to highlight in particular, and the internal usage of MyTile at TileDB today and how we use that in production. So what is TileDB? TileDB is the universal data engine. It's built upon a multi-dimensional array format, and this enables storing and accessing dense arrays. This could be images or video, sparse arrays, which can be things like LiDAR or genomics data or others, data frames, which is really any data in tabular form, most commonly SQL tables, and these are most commonly stored as sparse arrays, and also key value data sets, which are typically stored as sparse arrays also. So when we say universal data engine, we're really talking about a whole number of tools and integrations and details about TileDB itself and the format and the core library. So the TileDB core library is this multidimensional array store, and you can store any highly structured data in the TileDB format, and you can efficiently slice and do and perform computations on that data directly in the cloud. We have a number of efficient integrations with TileDB and APIs that are in Python, R, Java, C, C++, and more. We also have a number of efficient integrations with things like Dask and Spark and PrestoDB, and of course MariaDB, which we're going to talk about today. And this efficient integrations and APIs allows users to analyze their data with any tools that they prefer. If you are trying to use some Python machine learning packages, TensorFlow or Keras or something, you can use that directly with our Python API, or maybe you want to issue a SQL query via MariaDB or use PySpark. The options are completely at the user's disposal as we provide efficient integrations for the whole package. We also have a SaaS offering, TileDB Cloud, which expands upon the universal data engine and enables planet-scale sharing of TileDB arrays and data sets beyond just your organization, but to the public at large. And we also have a number of hosted components to TileDB Cloud to eliminate some of your deployment hassles. Hosted Jupyter notebooks for easy exploration, scale-out computations via serverless user-defined functions in languages like Python and R and others, and serverless SQL, which is built upon the MyTile storage engine, which we'll talk a little bit about later in this presentation. So some of the core features of TileDB and the format itself are it's cloud native, so you can store your data in S3, in Google Cloud, Azure Blob Store, along with things like HDFS, POSIX file systems, and more. We have a unique tiling and chunking format that provides fast slicing on your data and atomic I/O operations. It's a columnar format, so all of the fields and attributes are stored as independent files. We have a multitude of compression, encryption, and checksum filters, things like ZSTD, LZ4, and more. The entire library is built around fully multi-threaded implementation using modern C++ standards. We support massively parallel I/O operations, which works fantastically well with the cloud object stores. We have data versioning built directly into the format itself. This provides rapid updates and time-traveling capabilities. TileDB also supports arbitrary metadata on arrays. These are key value stores where you can put any type of metadata about an array on there. You can also have groups of TileDB arrays, and this entire thing is packaged up into a very nice embeddable C++ library. So some of the features about TileDB itself that I want to kind of dig into before we talk about MyTile are things around time traveling and the MVCC design that allows that. So to start with, every write in TileDB is immutable. Every write goes to a new, what we call fragments, and new objects are created. And updates are treated just as writes. They're completely immutable, and new files and fragments are created. And this is very important for cloud object stores where objects are immutable and you're not allowed to update single bytes. This also provides a number of benefits, time traveling being one of them. So if we look at the diagram that we have here, we have 3 writes that occurred. At T1, we wrote the 4x4 array. At T2, we wrote a subset. And at T3, we wrote a very sparse subset all over the place. After T3 occurs, the logical view of the array has all of the updates dispersed within it as you would expect. The power of TileDB and the MVCC design, though, is you're able to time travel and go back to any of the previous timestamps, T2 or T1, and open the array and access the data at that point and see the array as it was at that point. So if you open it up at, say, for instance, T1, you get to view and access the original data of the array before any updates were applied. Now, this object immutability is also very important with the crash safety of TileDB. So we'll talk a little bit more about the acidness in a moment, but you're crash safe based off this immutability. If a write fails, that fragment and that timestamp is simply ignored in subsequent reads. Now, a little bit of a technical note I want to hit before we move on is we do have something called consolidation supported. And as you expand this out, you can see that if you keep these timestamps over time and these fragments over time, there could be quite a lot of them. So we do provide the ability to combine and consolidate the fragments into a superfragment and purge out the history if you desire. This can reduce the disk space and can also potentially improve the performance. It's a complete optional feature. It's up to you, the user, whether you want to perform this consolidation and purge out some of your history or not. And then we or not. So TileDB supports the immutable objects, and that leads directly to our ACID support. So all writes in TileDB are atomic. I mentioned previously we have a tiling structure and a chunking structure. That gives us the atomic I/O units that we are able to write. Consistency is determined by the storage location. So TileDB, supports object stores, which are eventually consistent. We also support, POSIX file systems, which do support atomic operations there. With the eventual consistency of object stores, that's natively handled by TileDB. TileDB will always return valid results, and we will never return corrupt or invalid results for a query that's given. So the eventual consistency is built into the format. No external service is needed or external libraries or plugins or anything is needed to handle that. It's built into the format and that MVCC design. Isolation and durability is inherent in the MVCC design. Since every write gets its own fragment, which is basically a folder or a prefix, there's no collisions. Every fragment is unique with a timestamp and a UUID, so there's no collisions that occur between 2 writes. Transactions and locking are simply not needed for TileDB, and you get the full multi-reader, multi-writer design without this. Conflicting writes that happen at the exact same timestamp, while how unlikely do occur, those are handled natively by the UUID, and the ordering of that is based off the UUID. So let's talk about MyTile for a minute and go into the details about the MyTile, the storage engine based on the TileDB Embedded library. Now, one of the big benefits of MyTile is that it inherits all the functionality of TileDB itself. So it uses the Embedded C++ library, and now you can natively access through MariaDB TileDB arrays that are stored on remote cloud object stores like S3 or Google Cloud. We support full dynamic discovery in MariaDB, so you can simply run a query such as select star from an S3 path where a TileDB array exists, and it just works. It just works. You are able to query the cloud object store natively directly without creating tables or moving anything or doing anything but issuing a select statement. And we have complete interoperability with all the existing TileDB arrays and other APIs that we offer. The MyTile is based on TileDB itself. There's no semantics. There's no difference in the actual storage format itself. It is the actual TileDB arrays that are accessed and used directly in MyTile. Now, I do want to make a note ahead of time here that the MyTile storage engine is currently maintained by TileDB Inc. It's outside the MariaDB source. We are hoping to upstream that soon. Now that MariaDB 10.5 is out, big congratulations to everyone getting 10.5 GA'd. We're hoping to work to upstream that soon. So there's a number of features and optimizations that we've done with MyTile to work closely with TileDB to offer a lot of performance and benefit for the large workloads that we're targeting. We're targeting a lot of the large OLAP style workloads where you want bulk access, bulk writes, bulk reads to do large aggregations and things like that. So one of the first things that we did was support condition pushdown. So we do support the indexing and primary keys that you would expect based off the TileDB dimensions. However, we also built in support to MyTile for condition pushdown. And this provides an increase in performance for a large number of queries. The MariaDB Query Optimizer does a fantastic job, and it's a great piece of software. However, there's certain cases where the optimizer might choose not to use a certain index or might go a different route. And because we know that TileDB can handle certain predicates on dimension fields very efficiently, we intercept those predicates where possible and push that down and those operations down to TileDB to do more performant accessing of the data. Besides condition pushdown, we also optimize with multi-range reads, and this allows for high performance joins between TileDB arrays through MyTile and other tables in MariaDB. They could be InnoDB tables, they could be other TileDB arrays, but basically the MRR support gives us this bulk key access, which allows us to very efficiently and very performantly query the TileDB data to fetch the relevant parts that are needed in bulk to do that join. Let's also take a moment to talk about transactions and the locking support in MyTile. So as I mentioned, TileDB is a lock-free system for multi-reader, multi-writer. The TileDB storage engine and format itself natively handles the conflicts with the fragments, and so there's no need for any locking inside MariaDB. So MyTile itself does not implement any locking, and you get a completely multi-reader, multi-writer experience as you would outside of MariaDB. And without this locking, we still support all the ACID-like functionality that TileDB natively supports. And so you do get the eventual consistency of cloud object stores as kind of the main limitation and full ACID compliance there. But without any locking or transactions, you do get the same guarantees that exist outside of MariaDB with TileDB itself. Now, transactions are supported only for bulk insertion of data. So if you are inserting multiple records in a single transaction, that is supported, and those records will be collected and then committed at the final commit for a bulk insertion. However, no general transactions are supported, and the rollbacks and advanced things like checkpoints and whatnot are not supported at this time. TileDB itself does not have transactions. It does not need transactions for the ACID-like support that we have. However, it is on our roadmap to consider MariaDB single server transactions and add some level of support for that. And then also, we are looking in the roadmap to add some sort of orchestration layer or something for TileDB itself to support a level of transactions, as there are some edge cases where users might want those. Although, like I say, for most of the use cases, the multi-reader, multi-writer MVCC design of TileDB gives you everything you need and would expect from the general transactions. So one of the super cool things and things that I'm really excited about with MyTile is the usage of MyTile with the embedded MariaDB instance. So MyTile can be built and bundled into a single library with the embedded MariaDB instance. And we have customers that have used this, and we promote the use of this to facilitate exploring the data and do lightweight manipulation of your data. It works really great in combination with like a Jupyter Notebook to be able to access a TileDB array that's stored on a cloud object store without having to spin up a MariaDB server. So right from your laptop or right from a remote server in a single Python environment or other environment, you can query an array with SQL without having to spin up a remote server. And the MariaDB Embedded library is fantastic, and I know it doesn't get a lot of love in the community and not a lot of people use it, but it's really a fantastic little piece of software and mode that it can be compiled in, because the MariaDB library effectively has the same API as the MariaDB C connector. So you can drop the embedded library into a number of clients, such as one of the Python clients, you can do the Java client, the R client, anything that links against the MariaDB C connector, you can drop the embedded MariaDB into, and then get SQL queries working on TileDB arrays without needing to set up a server. Now, of course, there are some limitations of the embedded MariaDB instance. You're having to fetch the data to your local machine where it's running, and you're constrained by the resources of that machine. So if you're working on your laptop, you might be pulling data across the internet, and you have limited RAM and CPU resource. But we do think that it provides a lot of benefit for initial data exploration and lightweight usage. I want to take a moment to discuss backups with MyTile. So TileDB arrays are self-contained in the folder where they exist, or the prefix on an object store, and you can simply copy that folder. The array is always in a consistent state, even in the middle of a write. The MVCC design, we use special OK files to signal when a write has completed and when they show up with the eventual consistency. So at any point, even in the middle of a write, it's safe to copy the entire folder out or copy parts of the folder, and you won't risk any corruption of that backup. Only potentially an incomplete write that might exist. So this opens the door completely to the hot backups and incremental backups in a very, very simple manner. The structure of a TileDB array is very straightforward, well documented in the spec, but it's very straightforward even if you just list it yourself. And this opens up the possibility for you to make an initial copy of an array and then incrementally only copy out to backup the new fragments and the new parts that are written. TileDB arrays work fantastically well with tools like rsync or the AWS S3 sync commands or the equivalent Google and Azure commands. So it's very easy to copy the data sets around and have consistent backups. So we've talked a lot about what MyTile is, some of the features and some of the optimizations that exist. Let's talk for a minute about what it's not. So MyTile is not a general replacement for InnoDB. It's not geared toward the general transactional data sets and the highly transactional data sets that InnoDB supports well. InnoDB is a fantastic general storage engine that's been around for quite a while and has great support. And MyTile is more geared toward the OLAP and the large data sets, the terabyte size data sets, than it is for the highly transactional data sets that InnoDB does. Also, MyTile is not designed for full text search and indexing capabilities today, such as for storage engines such as Runga and others that are more specialized. TileDB gears more toward the general OLAP use case that exists. So let's briefly do a quick comparison between InnoDB and MyTile, and then we'll also look at MyRocks and MyTile. And to start with, I want to say this comparison obviously is at a high level. It's not complete. We're happy to discuss in more detail some of the comparisons after this session. Some of the advantages that MyTile has compared to InnoDB, of course, is first off, it's cloud native, so you can store your data on S3, Azure, or Google Cloud, full read-write support, and you're not limited to the data directory of MariaDB. Of course, you can write your array to the data directory. You can write it to a local file system or anything that we do support. There's also a large number of compressors that are supported by MyTile, ZSTD, LZ4, run length encoding, and more that InnoDB don't support. There's also significant reduction in write amplification. So we do not have a redo log or an undo log like InnoDB. So MyTile has a much less overhead for the write amplification that exists. We also natively support the time traveling without the need for system version tables or any outside libraries or tools to support that time traveling. And we also believe that compared to InnoDB, we're going to have much better performance at the terabyte scale. That large data sets are really what we target with TileDB. Although TileDB scales, from kilobytes to terabytes or petabytes, compared to InnoDB and the general use cases, we're really targeting the larger data sets. Now, there are some disadvantages of MyTile, of course. InnoDB is very mature, very battle tested. Like I said, it's been around for quite a while, used in probably millions of servers worldwide. So InnoDB has been around quite a while. InnoDB also has great support for replication and backups through tools like Maria Backup, Extra Backup, and Galera for cluster type environment. And InnoDB also has significantly better single record insert performance. Like I say, that transactional workloads that InnoDB really excels at, that we're not really geared MyTile toward. Now, of course, with these disadvantages, MyTile does support single record inserts. We've talked about how to do backups, and we do use MyTile in production today. So the fact that it's not quite as mature as InnoDB does not prevent anyone from using that in production. But InnoDB does have certain advantages for certain use cases, for sure. Now, Let's compare it to MyRocks. MyRocks is now pretty much the de facto standard for large data sets in TileDB. Large data sets in MariaDB. Since TokenDB has been deprecated and being removed from MariaDB, MyRocks is kind of the de facto standard to compare to. So some of the advantages of MyTile is we have cloud native support again, so you store that data on S3 or blob stores. There's also large interoperability with TileDB integrations or APIs. So that means that, with MyRocks, it's based off RocksDB. But there are some semantics that are involved there, so you can't quite query the underlying RocksDB key value store from outside of MariaDB, or it's not very common to. But with the MyTile, it's the native TileDB format. There's no special format, no semantics, and you can just query that array directly from MyTile or from anywhere outside of MyTile without any problems. There's also some differences in compressors offered between MyRocks and MyTile. We have some additional encoding, such as run length encoding, double delta, and several others. Now, of course, there's some disadvantages too with MyTile. MyRocks is more mature, and it supports additional things in MariaDB for statistics and parameters. MyRocks has a lot of built-in support for things like the performance schema and other statistics in MariaDB. TileDB itself has internal statistics, but not all of those are plugged into the performance schema and things like that. MyRocks also supports MariaDB transactions and checkpoints, where, like we said, MyTile does not, although MyTile does not necessarily have a need for the transactions to get the same level of ACID compliance that MyRocks does. So I'd also like to talk about a couple of use cases of MyTile that we have today. So the first one is we have a customer in the geospatial domain that has AIS location data. That's the lat long and other information about a ship. They store this data in sparse TileDB arrays today. And they have employees that access the data via a number of methods, including from Python directly, from MariaDB, and from the embedded MariaDB. And the great thing here is the employee can pick the tool they want for the job. From Python, they might be using the embedded MariaDB instance to run SQL queries directly. Maybe they're more comfortable with SQL than they are with Python, or they have a better familiarity with how to use bounding box queries and certain things in SQL, so they're able to do that. Or, also if they're trying to integrate maybe with some sort of mapping software, or maybe Pandas, data frames, or something else, they can use Python and access the TileDB API directly and use array semantics to access that. But the real power here is that the TileDB array can be accessed by the best tool for the job, or whatever the user is most familiar with, and they're not bound just to the SQL query. If they need a different type of integration, it is available to them. The other use case we want to highlight is a time series data set. So we have a customer that has a common time series data set of stock market and asset trading. They store the data in sparse TileDB arrays, and they use the embedded MariaDB to allow that fast and easy data exploration. So they're able to run queries directly from a Jupyter Notebook or from the laptop to explore the data and make some initial testing of maybe machine learning algorithms or something. Now, for their large jobs, they tend to use Spark or Dask or some other tool to run large distributed queries, which is great because we have the interoperability to do that on the exact same data set. But an interesting note about this customer is they've actually experimented with running distributed SQL queries via a cluster of independent MariaDB servers. So they spun up a handful of MariaDB servers. There's no cluster, no Galera, no communication between them, no replication. And at the application layer, they shard the query ahead of time and issue it to all the MariaDB servers in parallel. And because everything's lock-free, multi-reader, multi-writer support, they can run that computation in a largely distributed manner and then collect the results back at a single client. It's a very interesting use case and kind of shows some of the flexibility offered by MyTile and some of the advanced use cases. And I look forward to working more with that customer and experimenting more with things like Spider to do some of the sharding in a more automated fashion. So besides just our customer use cases, I want to talk a little bit about how we use MyTile internally to TileDB. And to do that, I want to highlight again that at TileDB, we have two different products. We have the TileDB Embedded, which is a fully open source storage library that's built on top of MyTile, and we've talked about here. And we also have TileDB Cloud, which I hinted about before, which is our SaaS offering of a hosted solution where you can do access control and sharing, and have hosted notebooks and serverless computations via both serverless user-defined functions in like Python or R, and serverless SQL. And that serverless SQL is powered by MariaDB and the MyTile storage engine. So we run a variety of MariaDB servers in an auto-scale cluster in an auto-scale manner, and we allow the user to query their data set remotely with simply just the string of the SQL. So here I have a little snippet of Python code where they're going to access this data and perform some sort of aggregation. They just give us the query, and what happens is that string is taken, shipped to MariaDB in our service. We run it, and we return the results directly to the user. It can be returned as a Python, as a pandas data frame in Python, or as JSON in any other language, or the user has some options depending on what they're trying to do. But the real benefit here is the MyTile storage engine is able to be used in this manner for this serverless SQL integrations that we have. It works, from a client perspective, it's very similar to the embedded offering of MariaDB. They just give a SQL query. They don't worry about running a server and maintaining the server. They're able to access remote data sets simply on MariaDB by issuing the query. The main difference and benefit here with the serverless SQL is you're not pulling the data down to your machine. So if you're on your laptop, you don't have to worry about pulling the data across the internet. You don't have to worry about the memory requirements on your machine. All the resources and connectivity is handled in the TileDB Cloud product itself. So that's it for the introduction to MyTile here today. I thank everyone for their time. We look forward to continuing to work on MyTile, to upstream it to MariaDB itself, and work with the wonderful folks at MariaDB to continue investing and promoting in MyTile. We hope that you found some of the use cases interesting, and we're very happy to answer any questions and to discuss more about MyTile and TileDB in general. Feel free to reach out to us at any of the contact information you see on the screen. We look forward to talking about MyTile more and discussing in detail with everyone here today. Thank you again.